Today we are going to do A-level 1990 questions 11 to 20. The first one, 11th question. White light is dispersed by a glass prism. When a white light incident on a glass prism, it will disperse into 7 colors. Among them, red has a least deviation and violet has a great deviation. Among them, red has the least deviation and violet has the highest deviation. In optics, you must know only 6 properties. In the last 45 years of past papers, they have asked only 6 properties of light. F, N, D, V, C, lambda. These are the only 6 properties they have asked up to now. It is easy to remember only for one color. I remember it for red. For red color, F and D are minimum. V, C, lambda are maximum. What is F? F is the frequency of the light. N is the refractive index. D is the deviation angle. Then V, velocity of the light in the medium. C is a critical angle. Lambda, obviously, wavelength. Therefore, for red, F and D minimum, V is lambda maximum. It is enough to remember only for red. But if they ask for other colors, you can able to get it from VibGeo. If all 3 properties are minimum for red, these 3 properties are maximum for violet and vice versa. For example, for red, VC lambda is maximum. Therefore, for violet, VC lambda will be minimum. Like this, you can remember the all 6 properties they have asked. Therefore, statement A is obviously correct. Red light moves faster than blue light through this prism. Among 7 colors, red has a highest velocity. Therefore, statement A is correct. Statement B. Deviation undergone by green light is less than the deviation undergone by the yellow light. Now they are talking with yellow and green. Therefore, we have to use this VibGeo. Right. We know red has a least deviation angle. Which color is close to red? Yellow is close to red. Therefore, if red is least, deviation of yellow that is close to red is lesser than deviation of green that is close to violet. If red has a least deviation angle, violet has the greatest deviation angle. Which color is close to violet? Green is closer to violet. Therefore, it has a larger deviation angle. Red has a least deviation angle. Yellow color is close to the red. Therefore, deviation of yellow is lesser. Deviation of green is larger. Therefore, statement B is given in other way around. That is wrong. Third statement, C. Refractive index of each color passes through this prism is different. Yeah, different colors have different refractive index. According to the amount of refraction, the refractive index will be varying. Red has a least refractive index. Then violet will have highest refractive index. Therefore, statement C is correct. In 2006 past papers, they have given the values of red as 1.51, refractive index of blue as 1.53. From this, we can able to get the refractive index of red is lesser than blue. These values are for a specific type of glass as crown glass. Different types of glass will have different values. Roughly, approximately, refractive index of glass is 1.5 and refractive index of water is 4/3. That means 1.33. And refractive index of air is 1.003. Roughly, it can be taken as 1. And exactly vacuum is 1. These are the normal values we are using in optics, right? Therefore, question number 11, answer number 4 is correct. Question number 2. Which of the following statements made about a stationary wave is not correct? Profile of a stationary wave will not move. It's a correct statement for a standing wave. The wave profile will be fixed. It can't move. Energy associated to this wave will not transmit with it. The second statement also correct. These are the direct theories. Energy will be inside the wave. It cannot transmit along the wave. But these 2 statements are correct for a progressive wave, but these 2 are wrong for a standing wave. For standing wave, wave profile cannot move Wave profile means the wave shape cannot move, and the energy also can't transmit along the wave. It will be trapped inside that wave. Right. Then third statement, two waves are needed for superposition. That is correct. They can move in the same direction or in the opposite direction. The same direction is wrong. Right. This is a definition of formation of standing wave. When two identical progressive waves traveling in opposite directions superpose, standing waves form. When two identical progressive waves traveling in opposite direction superposed, standing wave will form. Therefore, the most important condition, the both waves should be moving in the opposite direction to form a standing wave. Therefore, what they said in statement 3, they can move in the same direction is a wrong one. Opposite direction is correct, same direction is wrong. If one word is wrong, the statement is completely wrong. Therefore, answer for the question number 12 is third one. We'll check other two also. Superposition results some points which displacement is always 0. Yeah. When two points with the phase difference of pi superposed, they will form a 0 displacement. Those points are called nodes. Similarly, when two points with 0 phase difference, that means in phase points superposed, they will get added and the amplitude will be maximum. Those points are called antinode. They will be situated in between nodes, exactly in the middle of nodes. I'm repeating again, the points with phase difference of pi superposed, they will form 0 displacement points. They are called nodes. That means they undergoes destructive interference. The amplitude A minus A cancel out and become 0. But two points with 0 phase difference superposed, the amplitude will be get added. Therefore, with the maximum amplitude points will be formed. Those are called antinodes. They will be located in between nodes. Therefore, statement 5 also correct. Points which are in the middle of the 0 displacement points are the points with maximum displacement. They are called antinodes. Therefore, statement 5 also correct. Therefore, question number 12, third answer is correct. As an extra theory, we can say, what are the minimum requirements for the formation of standing wave? Two identical waves moving in opposite direction should superpose. Then how to get two identical waves? The source should be same. For the identical words implies the waves are identical. They should be identical in everything. It means their frequency should be same, their amplitude should be same, their wavelength should be same and everything. But their velocity need not be same. The speed should be same. That means they are moving in opposite direction. No, therefore velocity is not same. Their speeds are same. Then how to get two identical waves practically? We can send a wave and get it reflected from a barrier. Then the incident wave and the reflected wave will have identical properties. This is a practical way of getting two identical waves to get superposed. That's all. Question number 13 of 1990. Consider the following statements made about the speed of sound. Speed of sound in hydrogen is less than in air at the same temperature. What's the equation of speed of sound? V is equal to gamma P over rho is an equation. V is equal to gamma RT over M is an equation. Among these equations, the second one is best because here the pressure and density both will vary with each other. Therefore, we are going to select the second equation. Gamma is constant because for monoatomic gases, gamma is 1.66, that means 5 by 3. Diatomic gases, these are helium, neon, argon like normal gases. For hydrogen, oxygen, nitrogen like diatomic gases, it will be 1.40 exactly, that is 7 over 5. And for triatomic or polyatomic gases, it will be 1.33 or it can be 4 by 3 as a fraction. Therefore, here they are talking about hydrogen and air. Hydrogen is a diatomic gas. Air also mainly composed of diatomic gases, 70 plus percentage of nitrogen, 20 plus percentage of oxygen. Therefore, more than 90% of the air is composed of diatomic gases. Therefore, we can take the gamma of air as 1.4. Therefore, gamma is constant. R is always constant, 8.314 joule per mole per Kelvin. Temperature, they are talking in same temperature. Therefore, velocity of speed of sound, the speed of sound only depends on the molar mass and it's inversely proportional to root of A. V is inversely proportional to root of molar mass. Here, the molar mass of hydrogen is less, therefore, speed of sound in hydrogen is greater. What is the value of hydrogen? Molar mass of hydrogen is, you may say as 2, that is wrong. That is in chemistry you can use it in grams, but in SI unit in physics you have to use 2 into 10 to the power minus 3 kilogram, mole minus 1. Because here inside R, Newton, meter, mole minus 1, Kelvin minus there. Inside a Newton there is kilogram. If you want to cut kilogram and kilogram, the molar mass should be written in the unit of kilogram, mole minus 1. Then only it will be cut off. Right? Therefore, what is the molar mass of air? Air is mainly composed of nitrogen and oxygen. As we discussed earlier. Nitrogen molar mass is 28. Oxygen molar mass is 32. If they are in 1:1 ratio, 50-50 ratio, the molar mass will be, middle of them, it will be 30. But the percentage of nitrogen is more, therefore, it will be shifted, it will be closer to the nitrogen. Roughly, we can take the molar mass as 29. In chemistry, we calculated the molar mass of chlorine as 35.5 in the same way. By using the equation of relative abundance, we can able to get this one. Right. Therefore, roughly the molar mass of air is equal to 29 into 10 to the power minus 3 kilogram mole minus 1. Therefore, how many times the molar mass is increases? For hydrogen, it is 14.5 times roughly decreases. Therefore, root of 14.5, this is 3.8 times the velocity of hydrogen is greater than velocity of sound in air. Therefore, statement A is wrong. Statement B, when the temperature is increased, velocity of sound in air is increased. Yeah, that's the correct statement. V proportional to root of T. When other parameters are constant, velocity of sound in air is proportional to root of T. Therefore, when the temperature increases 4 times, velocity increases 2 times. There are so many possible questions like this. Therefore, statement B is correct. Statement C, velocity of sound in air does not depend on frequency. That is a correct statement. Velocity only depends on the properties of the medium. That means that gamma, the ratio of specific molar heat capacities, and the pressure or density or the temperature or the molar mass, they only depends on the properties of the medium. They are independent on the proper frequency or lambda. There is a possibility of confusion with the V is equal to F lambda. You may think when the F increases, the velocity will be increases. That is wrong. When the F increases, correspondingly, lambda will be decreasing. Velocity will be remain unchanged unless the medium change. Therefore, velocity is a property of medium, frequency is a property of the source. Here, unless a medium change, velocity will not change. Therefore, the velocity of sound in air does not depend on the frequency is a correct statement. Therefore, among them, B and C are correct, A is false. Therefore, question number 13, answer number 3 is correct. 1990, 14 question. Potential across AB of the network shown in the figure is V. Total charge stored in the network is. Therefore, due to symmetry, at this point, V by 2 voltage will be present. The total voltage across the two capacitors is V. Then at the midpoint, the voltage will be V by 2. If you want, you can take this potential as 0 potential. Then if you are going from negative to positive terminal, voltage will be increasing. Therefore, at this point, potential is V and here it is 0. Across two identical capacitors, V voltage is dropped. Therefore, at one of them, V by 2 will be dropped. At the midpoint, voltage is V by 2. Similarly, here also, the potential at the midpoint is V by 2. Therefore, potential difference across this capacitor is 0. What is the equation for the charge stored? Q is equal to C, or delta Q is equal to C into delta V. If the potential difference is 0, then the charge stored in the capacitor will be 0. Therefore, there will be no charge in the middle capacitor. The purpose of the capacitor is to store charge. If there is no charge is stored, we can remove the capacitor from the circuit. If there is no charge stored, we can remove the capacitor from the circuit. Then it will be an easy circuit. C and C will be series, no? There it will be C by 2. Similarly, bottom C and C will be series. Therefore, combination of 2C in series equal to C by 2. There are 2 C by 2 in parallel. Resultant is C by 2 plus C by 2 is equal to C. What's the question? The charge. Charge is equal to Q is equal to CV. Finally, it is connected to voltage V. Therefore, C into V is answer. Question number 14. Third answer is correct. How to get that C by 2? When two capacitors are in series, 1 over C plus 1 over C is equal to 1 over C bar, then the reciprocal is C by 2 is the answer. When two identical capacitors are in series, the resultant is C by 2. How to get C? When two capacitors are connected in parallel, C1 plus C2 is equal to C bar. Each of them are half of C. C by 2 plus C by 2 is equal to C. When two identical capacitors are in series connection, the resultant is half of the value of one capacitance. When two identical capacitors are in parallel, resultant is sum of the capacitors, or 2 times of one capacitance. Another method, we can paste the equipotential points. Here also potential is V by 2, here also potential is V by 2. We can paste those points. If you join them, it will form a shape like this. Here one C, another C, there are 4 C's are there. Now these two are parallel. Then C and C, if two identical capacitors are in parallel, resultant is sum of them, 2C. Similarly, here also C plus C is equal to 2C. They are connected to voltage V. If two identical capacitors are connected in series, the resultant is half of each of them. Therefore, resultant is C. It is connected to the potential difference of V. Therefore, charge store is equal to Q is equal to CV. Third answer is correct. If 4 identical capacitors are connected in a shape like rhombus or square like this, the resultant is one of the capacitance, that is C. The same technique can be used in resistors in Wheats and bridge also. If 4 identical resistors are connected in a bridge like this, the resultant is 1R. Here all are C, therefore resultant is equal to C. If a capacitance of C is connected to the potential of V, the resultant, the total charge is CV. Question number 15. 2 spherical charges are separated by a distance of 2 centimeter and exerting a force of 1.5 Newton. They are obeying Newton's third law. Therefore, each forces will be equal and opposite. We are taking the charges are positive, and if both of the charges are negative also, they will be repulsing. Right. If the separation between these two objects is increased to 3 centimeter, if the separation between these objects is increased to 3 centimeter, new force exerting on each other. Right. The Coulomb's equation for the electrostatic force is equal to F is equal to Q1 Q2 over 4 pi epsilon naught R square. Here in this question, the charges are not changed. 4 pi epsilon naught is a constant. Therefore, F only inversely proportional to R square. If the distance is increased, the force should decrease. Therefore, fifth answer will be wrong. Therefore, the total forces, the new force should be less than 1.5 Newton. Therefore, fifth one will be immediately removed from the choices. Therefore, you can substitute 2 times and get the answer. Initially, the force is 1.5 inversely proportional to 2 into 10 to the power minus 2 whole thing square. Now, the new force, let it be F, is inversely proportional to 3 into 10 to the power minus 2 whole thing square. This is the first equation, this is the second equation. It is easy to divide second by 1 first, because F will be directly gained. F is equal to F over 1.5 is equal to, then if you make it 4 over 9. If you cross multiply, 4 into 1.5 over 9 is equal to 6 by 9, that is 2 by 3 Newton is the correct answer. We can reduce the steps by putting in mind F inversely proportional to R squared. The distance increases from 2 to 3. Therefore, 1.5 times distance increases. It is in squared and it is inversely proportional to R. Therefore, force should be increased multiplied by 4 over 9. As R is multiplied by 3 by 2, force should be increases by 4 over 9. If initial force is 1.5, if it is multiplied by 4 by 9, answer will be 2 by 3 Newton. Therefore, question number 5, answer number 3 is correct. Question number 16 of 1990. Primary coil of an ideal transformer draws 0.1 ampere at 240 voltage. The output voltage of the secondary coil of this transformer is 12 volt. Current in the secondary coil. Therefore, this is a primary coil. Actually, it's a step down transformer. The initial voltage is given as 240 voltage, but the secondary voltage is, output voltage is only 12 voltage. And from the primary circuit, it draws 0.1 ampere. The question is the current flowing through the secondary circuit. Right. The equation for the transformer is Vp over Vs is equal to Np over Ns. The voltage is proportional to the number of coils and inversely proportional to Is over Ip. There is no relation to number of coils in this question. Therefore, we can relate potential and the current directly. The potential is 240 initially, secondary is 12. Secondary current is a question, the primary current is 0.1. If you cross multiply, then 24 over 12 is equal to Is, that is 2 ampere. The correct answer is fourth one. Method 2, you can directly do without applying the equation. The voltage is decreases by 20 times as it is a step down transformer. Therefore, current should be increases 20 times because the power should be constant. As it is an ideal transformer, the power should be constant. Therefore, if the voltage is decreases by 20 times, current should be increases by 20 times. Therefore, 0.1 into 20 is obviously 2 ampere current is flowing in this secondary circuit. Then answer is fourth one. If you want to get the proof for this equation, this also came from the same power equation. Efficiency is equal to 100%. Therefore, we can assume power input is equal to power supply is equal to power output. Power input is equal to Vp into Ip. Power output is equal to Vs into Is. Then if you subject voltage to the same side, Vp over Vs is equal to Is over Ip. This is a proof or derivation of this equation. Then if they ask the now ratio of secondary coils in 2024 NEET paper also they ask a similar question. The ratio of number of coils Ns over Np, Ns over Np, that will be 1 over 20. There may be a careless mistake of 20 over 1 or 1 over 20. As it is a step down transformer, Np should be greater than Ns. Then if there is a power, you can either multiply primary voltage into primary current. Power is equal to 240 into 0.1, that is 24 watt. Or if you want, you can multiply secondary current into secondary voltage. The power output is equal to 12 into 2, that is 24 watt. If you want, you can equate the both powers. As efficiency is 100%, the power input should be equal to power output. So, seventh question. When comparing to a single cell with negligible internal resistance, many similar cells are connected in parallel will produce. It's a one cell directly connected to a resistor. If two identical cells are connected in parallel to the same resistor, here the potential across the battery is E. Therefore, across the resistor also the same potential will be there, E. Then the current flowing is equal to E over potential difference over resistance. Similarly, if the potential is 0, the potential difference across the battery is E. It is parallel, therefore here also the potential difference is E, and across the resistor also the potential difference is same E. Same potential difference same resistance, therefore current flowing will be also same, that is E over R. In the both circuit, the current through the external resistance is same. But here two batteries are contributing to that current. Each of them are giving I by 2, half of the current, and they are getting added, and total current I is flowing through the resistor. I by 2 means through a battery, current of E over 2R is flowing. From the other battery also, E over 2R is flowing. Both of them get added, and to the external circuit, E over R current is flowing. Therefore, what about the current? Current flowing in both directions will be same. If you draw in a graph, there are so many past papers questions to draw the graph of variation of current with time. Current will be same in both instances, but the time of duration of current flow. If you consider the charge of a battery, in identical batteries, the total charge stores will be same. In both batteries, charge will be same. But here the current flow is E over R. Here the current flow is E over 2R. 2 times the current flow is decreasing. Therefore, time should be 2 times more. The time taken for the battery in the first instance is T1. Then the time taken for the battery to discharge in the second instance will be almost twice that of first one. Therefore, question number 17 of 1990, the best answer is fourth one. Will give the same current to the external circuit, but for more time. And this is a graph for that. You can explain with the energy also. Now I explain with the help of charge. We can explain the same concept with the help of energy also. Here, one battery has an energy of E, means the two identical batteries have the total energy of 2E. Therefore, you can equate with the energy is equal to power into time, method 2. Total energy is doubled. This is not EMF, this is the power energy. Total energy is doubled. The power is same for both instances. Therefore, time is double. How to get the power is same? You can apply P is equal to VI. In both instances, the voltage is same E. The current is same. Therefore, power in the output circuit will be same. Therefore, in both instances, powers are same. Energy in the second instance is twice of first one. Therefore, time is also twice. We will check the other answers. It will produce higher voltage. That is wrong. The voltage will be same in both instances. We will give the higher power to the external circuit. No, power will be same. Just be proved. Third one will higher current is wrong. The same current in both instances. Fourth one is the best answer. Same current, but the time is double. Fifth one, give more power to the external circuit, but for more time. That is wrong. Time is more, but the power is same. Therefore, question number 7, answer number 4 is missed. There are some other past paper questions with internal resistance. Here, the internal resistance is 0. It is given as negligible internal resistance. If it is not negligible, then the answer will be different. The current flowing in the first circuit will be I1 is equal to E over R plus R. I2 will be E over R plus R by 2. Right. Question number 8. Equivalent resistance of the network connected to the batteries. Here we have to start from the method 1, we have to resolve properly. Then there are shortest ways also. Here if you want to resolve them, you have to take the outermost point without disturbance. Then it is easy. I will select this first. Here the same current is flowing through these two resistors. As the same current is flowing, they are in series connection. Series connection in all levels we studied. The resultant of resistance is R1 plus R2. Therefore, instead of R plus R, you can directly put 2R here. If the same current is flowing through the resistors, they are said to be in series connection. If it is in series, the resultant is R1 plus R2. Therefore, R plus R is 2R. Now, consider these 2 points. within this point, the current is getting divided and joining again. Therefore, within these 2 points, the resistors are said to be in parallel connection. The current is getting divided and getting joined again. Therefore, 2R and 2R are parallel. The resultant of 2R and 2R is R. Then if you are slow and if you want to do properly, 1 over 2R plus 1 over 2R is equal to 1 over R bar. And then if you take the LCM and solve them, answer will be R. But you can directly put the resultant of 2R and 2R is equal to R. Here you can remove it. And instead of these 2, you can put R. Now, here also, always try to do from the outermost point. Don't disturb these intermediate points. Therefore, here it is isolated and outermost. You can directly solve them. These 2 are series. Obviously, the same current is flowing through these 2 resistors. They are in series connection. Therefore, R plus R is series. Then you can cut it off 2R. Now check these 2 resistors. The current is getting divided at this point and again joined at this point. Therefore, resistance within these 2 points are said to be in parallel connection. Therefore, resultant of 2R and 2R already we calculated as R. Therefore, we can remove these 2 R's and put only 1 R. Now, finally, it is obviously series, same current is flowing. Then resultant is R1 plus R2. R plus 2R is equal to, resultant resistance is equal to R plus 2R. Then the resultant is 3R. This is the answer for question number 8, third one. But actually it takes some time. How to do faster in one step? Here you can do by mind without touching pen. If there is no resistors connected to the right side of this 2R, then only these 4 are there. But if you are connecting something in parallel, the resultant will be less than the 4. But something is getting added to 2R, therefore obviously this is greater than 2R. There's only one answer, greater than 2R and less than 4R. The answer is 3R, third one. I'm repeating again. Something is connected in series to 2R. Therefore, answer is 2R plus something. Therefore, it should be greater than 2R. And if there is no resistor network to the right side of this one, if you remove this one, if you forget this part, 2R plus 2R is equal to 4R. But something is connected in parallel to this 2R. If you are connecting something parallel, the resistance will be less. Therefore, resultant should be less than 4R, but it should be greater than 2R. Therefore, only one answer, 3R. If it is less than 4R, you can eliminate the answers 5th and 4th. If it is greater than 2R, you can eliminate the answers 1 and 2. Therefore, third one is the only remaining answer. That's all. 19th question of 1990. The person of weight 760 Newton on Earth goes to Moon. Right. The weight on Earth is equal to 760 Newton. Weight can vary place to place, but the mass cannot. Therefore, you can write weight is equal to mass of the man into gravitational acceleration on the surface of Earth. It is 10. It will be not given in the question individually, but in the top of the paper, the data is given as G is as 10. Therefore, for all questions, you can take G as 10 unless it is mentioned as 9.81. If it is 9.81, they will mention. Otherwise, you can take it as 10. Therefore, 760 is equal to m into 10. Therefore, m is equal to 760 divided by 10 is equal to 76 kilogram. I didn't mention as Earth or Moon. That means mass is same everywhere. Now he is moving to the surface of the Moon. On the Moon, the gravitational acceleration is G capital M R square. If he has the weight at Moon, you have to multiply the mass is same everywhere, into gravitational acceleration of Moon. Therefore, mass is 76. Gravitational acceleration at the Moon is equal to Gm over R squared. Then the best answer is second one. Obviously, you can eliminate the answers 1, 3, 4, 4 and 5 also with the dimension. Actually, first one, the weight and G is multiplied. 760 is already weight. Weight and G is multiplied, that is meaningless. Second one, mass and gravity is multiplied. Third one, 1 over weight into G, that is wrong. Fourth one, 1 over mass into G, that is wrong one. Fifth one, only G. Fifth is answer if they ask gravitational acceleration on the moon. If they ask gravitational acceleration on the moon, the answer will be fifth one. Therefore, that is G. Therefore, according to the dimension also, you can guess answer is second one. The water column is trapped inside a vertical capillary tube as shown in the figure. Which of the following graphs best represent the variation of pressure P along O1? The theory is the pressure will be high inside the spherical surface. The excess pressure is equal to P2 minus P1 is equal to 2 T over R. The excess pressure inside a liquid droplet is equal to 2 TOR. Here T is the surface tension of the liquid, R is the radius of the spherical surface. Right. Therefore, you must know if you are entering into the convex surface, the pressure will be high. Right. And vice versa, if you are leaving the convex surface, pressure will be low. Therefore, here this is inside the sphere, the pressure is atmospheric pressure. Everywhere it will be same almost. Here also atmospheric pressure. If you just come below that point, here the pressure will be pi minus 2T over R1. The radius are different if I am putting R1 and R2. Therefore, the pressure drop at this point is equal to 2T over R1. Therefore, pi minus 2T over R1, the point just below the meniscus. Right. With depth, pressure should be increasing inside the liquid column. With depth, pressure should be increasing. The rise of pressure is H rho G. H is the height of the water column, rho is the density of water, G is the gravitational acceleration. Therefore, at this point, pressure will be added pi minus 2T over R1 plus H rho G. Right. Again, we are entering into the spherical surface. Here we are leaving the spherical surface, the pressure is reduced. Therefore, if you are entering into the spherical surface, pressure should be increased. Here, just below that point, pressure is pi minus 2T over R1 plus H rho G plus 2T over R2. If you take this R1 and R2 are same, they will be cut off, but actually they are not same. I am going to explain that. R1 and R2 are not same, therefore you can't cut it off. Therefore, the pressure inside this point is pi minus 2T over R1 plus H rho G plus 2T over R2. Everywhere the same air, therefore at this point and at this point, pressure is almost same. Actually they are equal to the pi. This is open place now, therefore the pressure, atmospheric pressure is pi. The top also pressure is pi, at the bottom also pressure is pi. But in all 5 answers, it is given as same pressure at O and Y. Therefore no need to worry about that. Now we are going to draw the graph properly. This is O. From O to A, the pressure is pi. At the point of A, there is a drop of pressure. Drop is 2T over R1. Then from A to B, pressure increases gradually. Again, at B, there is a sudden rise of pressure. And finally the pressures are pi. The rise is equal to 2T over R2. The pressure increase along the liquid water column is H rho G. These are the data, and the initial and final pressures are same pi. This point is B, this is Y. The best graph that explains these variations is first one, but you can eliminate in one step. The only graph with H rho G increment is first one. In all other four answers, there is no increase of pressure along the depth. Along the depth, pressure should be increasing in liquid column. Therefore, along water, pressure should be increasing. The only answer is first one. You can eliminate the other answers in other ways also. Answer 3, 4, 5 can be cut off because there is no drop when we are leaving a spherical surface. When you are leaving a spherical surface from inside to outside, if you are moving from inside of here to the outside, pressure should be dropped by 2 TOR. Therefore, third and fourth and fifth, there is no drop of pressure. Therefore, they are eliminated. Among 1 and 2, second one is eliminated because the H rho G increment is not mentioned. Therefore, the most suitable answer is first one. Here we are going to talk about, I already told in the start of the question, we had to check whether R1 or R2 is high. From the figure also you can get, but those are rough figures. We are going to do correctly. Here 2T over R1, the pressure increment is high, 2T over R2 is low. That means 2T over R1 pressure drop is, magnitude of this pressure drop is greater than 2T over R2. Same liquid, same surface, therefore 2T and 2T will be cut off. Same liquid, same surface, therefore surface tension will be same, therefore 2T and 2T will be cut off. Therefore 1 over R1 is greater than 1 over R2. If you make it reciprocal, the inequality will be changed. R2, R1 is less than R2. The radius of the top sphere is less than radius of the bottom sphere. We can explain in physics also. Here the liquid column is pressing on the waters, the meniscus. It is get further flattened than the first one. Initially the curve will be like this. Due to the pressure of the water column, it will get further flattened. Therefore, the radius will be smaller in the top sphere. Radius will be larger in the bottom sphere. Therefore, R1 is less than R2. That's why the drop of 2T over R1 is greater than 2T over R2. Therefore, best answer for question number 10 is first one.